Quantum mechanics. So I've started a course on quantum mechanics, and in this I will cover the whole quantum mechanics in the form of lectures, right? And those who want to visit the Hindi version of it, they can visit my channel and Philosophers Academy, and they can go to the playlist section. In that I've uploaded 2 lectures in Hindi also, and I am uploading more lectures on it day by day, right? So this is, I've started in English now, and so that it can become a universal content also for everyone, right? So it will help to grasp information on quantum mechanics worldwide. If it were in Hindi only, then it was only applicable and accessible to the people who knew Hindi, right? So that is why I thought to make it in English also. So there are 2 separate playlists now. And the one will be in English and one will be in Hindi. Whatever language you are comfortable, you can watch it, right? So let's start the video, and please do subscribe to my channel, and let's start. Okay. So before knowing quantum mechanics, we have to know that what is physics, right? Because quantum mechanics is ultimately a part of physics. So what is physics? Well, physics is a branch of science which deals with nature. A very common definition of physics, but I don't agree to it, nor you should also, after listening to my statement, of course. Well, if we see that physics, it is a fundamental thing, right? And it deals with our daily life. For example, we are sleeping, walking, or anything. So, saying it is a part of science, it neglects something, that is our life. Sometimes we say that science and life are 2 different aspects, but in reality, they are not. So, it is better to say physics is a part of our life and sciences which deals with nature, if we term science and life as different aspects. But if we say science and life are same aspects, just they differ a bit, but it don't matter. So physics is a part of our life, and science which deals with nature should be the complete definition of physics, according to me. Rest definitions can be many, whatever you want. Okay, so physics can be further bifurcated into 2 parts. What are these parts? Well, physics can be bifurcated into theory of relativity, okay, and quantum mechanics, right? Okay, so what is theory of relativity? I will make a course on it in some days once I complete the quantum mechanics. Then you will understand it better. But for now, it is something which deals with the particles moving close to the speed of light or at very high speeds, right? Particles moving close to the speed of light, right? Okay. And what is quantum mechanics? Quantum mechanics is a branch of science which deals with the minute particles, very minute particles. For example, atoms, electrons, protons. I mean, very minute particles. It can be said as an extended version of classical mechanics. Like in the Newtonian era, we used to think that physics is a fundamental thing. That was fine. But Newton said that space and time are different things, are different aspects. But Einstein told us that space and time are not different, just they are the same aspects of a one single thing called space-time, right? So that is it all about relativity. Rest we will cover in our course of special and general relativity. So let's start with quantum mechanics. This is our first lecture, so it will be very basic, so we don't need to worry much about it, and I will cover everything from basics to infinite level. Okay, so okay, suppose you are having a jar. Okay, fine, you throw some light on it, maybe it a laser. Okay, Basically you are throwing radiation on it, right? Okay, suppose this is air and suppose this is water, right? Okay. Okay, light enters. Okay, it is better to say radiation instead of light, because many times with light we refer to the spectrum range from of Vibgyor, right? So it is better to say radiation, because in that we include from microwave or from yeah, from microwave to gamma or cosmic rays, right? So it is better to say radiation. I'm removing this shaded part because I need to show the path of light. Okay, but understand this is water and this is air and this is also air. Okay, so when light hits water, it will refract for sure, right? Okay, but it won't only refract, it would also reflect from the surface of water, that is like this. Suppose this angle is r prime, right? Okay, well, the angles don't matter for now because we are just dealing with some experiment sort of thing, right? So what basically is happening here? Okay, so first of all, we all should know the biggest statement, the most fundamental statement of quantum mechanics, that is a truly identical experiment done multiple times may or may not yield same results. This is the statement of quantum mechanics. But why? Because in classical mechanics we used to say that if we are doing an experiment, then we are doing the same experiment again and again, we expect to get the same results all the time, right? For example, if there is if this is marker, right, and if I give it a force, suppose 10 newton, and it has a mass of 2 kg, for example, just so by F is equal to ma, we calculate that A is equal to 10 by 2, that is 5 meter per second square, right? But so from that we have found the acceleration. We know that it has initial velocity of 0, and if we neglect the air resistance and friction on my hand actually, so what will happen? Well, we can exactly predict where it will fall and what will be its trajectory, right? It will be parabolic, and where it will fall we can use some mathematical tools and we can predict it. And in fact, you can take any body which has a mass of 2 kg and apply 10 newton force, it will surely do the same thing that this marker will do. But then why quantum mechanics is so weird? So for quantum mechanics, this is the statement, but for classical mechanics, what was it? It was a truly identical experiment done multiple times will yield same results. This was the statement of classical mechanics, but the statement of quantum mechanics is that a truly identical experiment done multiple times may or may not yield the same results. And it is something really amazing. It tells the probabilistic nature of the quantum mechanics, right? So it is really amazing thing to imagine something like that, something like it is too out of box, because generally whatever we see in the nature, it seems to be very much absolute or predictable, but there is no surety of surety in quantum mechanics. There is nothing 100% sure event in quantum mechanics, right? Okay, so what this has to do with this? Well, suppose you had 100 photons, right? You had 100 photons and you throw it in and you emit it over the surface of water, right? Okay, and there is a probability that 80% will refract and 20% will reflect, right? So we would expect that this photon, that out of 100 photons, you can surely say that 20 photons will reflect, right? Okay, and the remaining 80 photons will refract. Okay, it means out of 100, 80 will go for refraction and 20 will go for reflection. Okay, but what if I say instead of many photons you have a very few amount of photon, for example one photon only? Then you can't say that with that either it will reflect or refract, because you have only one. You can only tell its probability that it will go, that there's a 20% chance that it will reflect and there's a 80% chance that it will refract. There is nothing like surety. Before, you were sure that 20 photons will reflect and 80 photons will refract because there were many photons. But if you have very less amount of photons, then you can't predict everything, right? About that single photon. It means, just imagine, you emitted this photon and first time it refracts, right? Okay, and second time when you emitted it, then it reflected. It means you done the same experiment twice. What was that? Emitting the photon on the surface of water, but both the times you got the different results. First you got refraction and second you got reflection, and that is quantum mechanics. Means a probabilistic world where here you are also dealing with the probability only, right? That's why. Okay, and one more thing, this behavior proves the wave nature of light. Okay, this is the most important statement of quantum mechanics. Okay, so now first we done reflection and refraction. Okay, and second is diffraction. For experiments, I have already posted a video on diffraction and Tyndall effect. You can check out them. So for better understanding, maybe, right? It will be in my channel only, right? So you can visit it. Diffraction. So diffraction, it states that means it proves the wave nature of light. We all know it, right? Diffraction, it proves the wave nature of light. And then we got interference. Okay, which prove the wave nature again. In fact, polarization, it also proved the wave nature, right? So there were something really amazing aspects of physics at that time. But the problem came by a experiment on black body. What was it? It was the Wayne displacement law, which made the scientists believe that the light or the radiation is made up of quanta, that is the small packets of energy, which was further named as photon. Okay, so the first experiment which was done to prove it was theoretically it was photoelectric effect. There were many other experiments also, but the most significant one is photoelectric effect, and it proved the particle nature of light. So how is it possible that light in many aspects it's behaving like a wave nature, and in some aspects it is behaving like particle nature? How is it possible? Well, it led to a simple conclusion that of wave particle duality, which means any object, any object you take, be it you, be it me, be it this board, be it this marker, or anything in this universe, everything has a dual nature, that is the particle and a wave nature also. Just this wave nature is more significant in the particles which are very minute and very small. For example, in the cases of atoms and electrons, photons, and many other things. And when we go to the macro scale, that is the macroscopic world, that is the classical world, we don't see it much significant, because we will discuss more about it in De Broglie. But for now, we should know that in classical world we just don't experience it, and more on it in my next lecture. So I hope that you all understood it, and please do subscribe to my channel, and I will continue making this these videos to enhance your knowledge. So thanks a lot for watching it, and do subscribe to my channel.